Everyone, this is the second video of the topic deflection of beams. In the first video, I have explained how to find out the slope and deflection of a beam using the standard formula method, and also I have wrote some of the general standard formula which are very helpful in finding out the slope and deflections in a beam. In this video, we will solve some of good questions of deflection and slope in a beam. So let's start with our first question. Our first question, we have a cantilever beam of total length 2L, L and L. Say this point is A, this point is B and this point is C. Region BC carries a UDL of magnitude W Newton per meter. We have to find out deflection at point C and theta at point C. To find out the deflection at point C and theta at point C, we will first shift this UDL from region BC to point B. We will have to shift this uniformly distributed load to point B. We will shift this load as this is B and this is C. So this UDL is of magnitude W into L, WL, and it can be assumed to be concentrated load at a distance of L by 2 from B. Means the UDL can be assumed to be a concentrated load at the center of the span, means at a distance of this L by 2 from B and L by 2 from C. The magnitude will be W into L. So now we have to shift this WL to point B. So here we get W into L, point load at B, and a moment of WL into L by 2 in clockwise direction, because this is in downward direction. WL into WL by 2, WL into L by 2 is equals to WL square by 2. So in this way we shift the load. Now we will draw the deflection curve of the beam. So this is our reference axis of the beam. So due to this point load WL and a moment WL square by 2, region AB will deflect in this sense, and due to this deflection the BC will also deflect in a straight line. So what is this? This is delta B with respect to A. This is B, this is C, this is A. Deflection of B with respect to A, and this is theta B into L. This is theta B into L, because this is theta B, and again from the triangle this is angle theta B, this is say L, so this is theta B into L. So this is theta B into L, and in the region BC we have a UDL, uniformly distributed load, so this region will again deflect in this manner. So this is delta C with respect to B, means deflection of point C with respect to B. So what is the total deflection of point C with respect to A? Is deflection of B with respect to A plus theta B into L plus deflection of C with respect to B. So this is our total deflection value. So what is deflection of B with respect to A? Deflection of B with respect to A is due to point load PL cube upon 3EI and due to moment M, ML square upon 2EI. So it is P, which is WL, PL cube upon 3EI plus m, which is WL square by 2m L square upon 2EI. This is delta B with respect to A plus theta B into L. So what is theta B? Theta B due to point load is PL square upon 2EI, and due to M it is PML upon EI. Due to moment M it is ML upon EI. So it is PL square upon 2EI plus M WL square by 2ML upon EI into L plus delta C with respect to B. Delta C with respect to B is due to a UDL, and due to UDL deflection value is WL की power 4 upon 8 EI. So this is WL की power 4 upon 8 EI. So we take value WL की power 4 upon EI as common. So the value is 1 by 3 plus 1 by 4 plus 1 by 2 plus 1 by 2 plus 1 by 8, which is WL power 4 upon EI into 41 by 24. So this is the value of delta C with respect to A. So we see that the deflection at the free end C is 41 by 24 into WL की power 4 upon EI. Now let us find out the theta value. So theta C with respect to A is theta B with respect to A plus theta C with respect to B. So theta B with respect to A. Theta B with respect to A due to point load is PL square upon 2EI, and due to moment M it is ML upon EI, is due to PL square upon 2EI plus M L upon EI plus theta C with respect to B is due to a UDL, which is WL cube upon 6EI. Take common WL cube upon EI, which will give 1 by 2 plus 1 by 2 plus 1 by 6 is equal to 7 by 6 WL cube upon EI. This is theta C with respect to A. This is the slope value at the free end. So we see that the direct formula method, how simply we calculate the value of slope and deflection at the free end. Now next we find out the slope and deflection in frames, which is our second question. In our second question, we have given a frame, or specifically a 90-degree frame, because the angle between its two parts or two parts is 90 degree. This is B, this is A. Vertical section is fixed. This is C, and at point C there is a point load of magnitude P. This is length L, this is length L. BC is of length L and SB is also of length L. We have to find YC horizontal and YC vertical. So again we will shift this P, point load P, to point at from point C to point B to find out the deflection in vertical section AB. This is our section. This is point load P. On shifting this point load from B to C, we get a point load P here and a moment equal to P into L in clockwise sense. The moment value is P into L. Now we draw the deflection curve. This is our reference. A, B and C. Due to this point load P and moment PL, this vertical section AB will deflect in this manner, AB dash, and due to this deflection, this BC will deflect in this manner. It is a straight line. So what is this? This is theta B into L. What is theta B? This is angle theta B. So vertically opposite angle, this is also theta B, and this angle is 90 degree. But in the region B to C we have a point load P, so this straight line will deflect in this manner. And what is this? This is delta C with respect to B. Delta C with respect to B. So this total is delta Y and this total is delta X, which we have to find. In the vertical section AB, we have a point load P acting axially to the section and a moment PL. Look, this point load P due to this point load P acting in axial direction, there is no deflection in the beam because it will cause axial strain or axial stress in the member AB. It will not cause any deflection. So deflection will be only due to moment PL. So what is the deflection due to moment? The deflection due to moment is ml square upon 2EI. So value delta H is equal to m, which is PL, L square, ml square upon 2EI. So delta H is PL cube upon 2EI. So this is the value of delta H. Delta Y value is theta B into L plus delta C with respect to B. So theta B is due to moment M, which is ml upon EI, ml upon EI, ml upon EI into L. Delta C with respect to B is due to point load P. This is the region member BC. So in deflection at point C with respect to B is due to point load at free end, which is PL cube upon 3EI is equal to PL cube upon EI. 1 plus 1 by 3 is equal to 4 by 3 PL cube upon EI. So this is the value of delta y and this is the value of delta h. Let us move to our third question, which is a frame P3, or say specifically a 90-degree frame which is hinged, whose up vertical portion is hinged. This is point A, this is point B, and this is point C. It carries a point load P at end C. So first we will shift the point load P from point C to point B to find out the deflection in AB, and then we will draw the deflection curve. So to shift this point load P, we will get here a point load P in vertical direction and a moment, this length is L and this length is L, and a moment equal to P into L. This is A, this is B. Here we get a point load P and a moment equal to P into L, and in the horizontal region we have a point load P. This is B and this is C. So let us find out the deflection curve of this frame. This is our reference frame. Vertical portion is hinged, so this portion will deflect, vertical portion will deflect in this manner, and due to this deflection this will be a straight line, and this region, horizontal arm of this frame, also carries a point load P, so this will again deflect. Okay, so this is say theta B, this is A, this is B, and this is C. This is theta B, so this will be again theta B. So this is L into theta B, and this is deflection of C with respect to B. So what is deflection of C? Deflection of C is equal to L into theta B plus deflection of C with respect to B. So what is theta B? And this theta B is due to a moment PL only, because this vertical load P is axial to AB and it will cause no deflection in AB. So due to moment M, the theta is ML upon EI. So it is L into theta B is M, which is M L upon EI plus delta of C with respect to B. Delta C with respect to B is due to point load P, which is PL cube upon 3EI. This theta B is due to moment M, but this is not a cantilever beam. This is not a cantilever beam. This is a simply supported beam having a movement at one of its end. So the theta value is ML upon 3EI. Theta 2, where the external moment acts, is ML upon 3EI. Remember, this is a hinge. This vertical section is hinge. So this theta B is ML upon 3EI. ML upon 3EI. Okay, let us take common PL cube upon 3EI into 1 plus 1, which is equal to P 2 by 3 PL cube upon EI. So this is delta C at this free end. And what is theta C? Theta C is theta B plus theta C with respect to B. So theta B is ml upon 3ei, ml upon 3ei plus theta C with respect to B. Theta C with respect to B is due to point load P. So the theta is P L square upon 2 ei, 5 by 6 PL square upon EI. So this is the value of theta C. So here we find out the value of delta C and theta C, means at the free end of this frame. Let us move to our next question. Cantilever beam is nothing but a cantilever beam having a support at its free end. Propped cantilever beam is nothing but a cantilever beam having a support at its free end. Say this is a cantilever beam. It is simply a cantilever beam AB, and the same cantilever beam AB, when supported at its free end by a simple support, so it is a propped cantilever. So it is a propped cantilever. So let us solve one of the question of propped cantilever, which is P4 of this section. In this question, a cantilever beam carrying a uniformly distributed load and is supported at its free end. The magnitude of uniformly distributed load is W Newton per meter. So we need to find out, this is point A and this is point B, so we need to find out the reaction at B. So how we are going to find reaction at B is by simply find out the deflection due to W and the upward deflection due to the reaction at B. So this is the deflection curve of the beam due to load W. This is the deflection curve of the beam due to the load W. Since it is simply supported at point B, so this deflection is counteracted by the deflection of reaction at B. Deflection due to UDL is equal to upward deflection due to reaction force at B. What is the deflection due to UDL? Deflection due to UDL is WL की power 4 upon 8 EI. So it is WL की power 4 upon 8 EI is equal to upward deflection due to reaction force at B. Reaction force will be in upward direction. So let us say this is RB. The reaction due to point, and the deflection due to point load is PL cube upon 3EI. So it is will be equal to PRB L cube upon 3EI. So here we find out the value of RB is equal to 3 by 8 into WL. So in this way we find out the reaction forces in the case of a propped cantilever. Let us solve the next question of propped cantilever. Our next question, P5, we have a cantilever beam carrying a point load P at its free end and supported by a spring support. The length is A, this point is say A, this point is say B. The spring constant or stiffness of the spring K is given in the question. We have to find a reaction at point B. So here also we equate the deflection. So this beam will deflect in this manner. Means deflection due to P in downward direction minus upward deflection due to RB minus upward deflection due to RB is equal to compression in the spring. Deflection due to P in downward direction minus upward deflection due to RB is equal to compression in the spring. Let us say our sign convention is negative is positive. In downward direction it is positive and in upward direction is negative. So deflection due to P is PL cube upon 3EI. PL cube upon 3EI minus upward deflection due to RB. Upward deflection due to RB. RB is acting in upward direction minus RBL cube upon 3EI. It also acts as a point load in the beam. So the formula is same. RBL cube upon 3EI is equal to compression in the spring. We know that the spring formula is force is equal to K into X. Deflection is force upon K. RB upon K. From here we find out the value of RB. PL cube upon 3EI is equal to RB 1 by K plus L cube upon 3EI, which will give RB is equal to PL cube upon 3EI upon 1 by K plus L cube upon 3EI. This is the value of reaction at point B. Reaction at point B. So we equate the deflection using a sign convention and we find out the value of RB. Let us move to the next question. In the next question, say P6, we take the example of a simply supported beam carrying a uniformly distributed load of magnitude W Newton per meter, and here we have one more support at the middle section. Total length is 2L. So we need to find out the reaction at B. So here also we equate the deflection this beam will deflect in this manner. This beam will deflect in this manner if there is no support, but the reaction at support B will counteract this deflection. So we equate the two deflections, means deflection due to UDL is equal to deflection due to reaction at B. So what is deflection due to UDL? Deflection due to UDL is 5 upon 384 WL की power 4 upon EI. It is 5 upon 384 WL की power 4 upon EI is equal to deflection due to reaction at B. So the deflection due to point load in a simply supported beam is PL cube upon 48 EI. So it is RB L cube upon 48 EI. So from here we can easily find out the value of RB, which is 5 into 48 upon 384 into WL. So this is the value of reaction at point B. So now we know that how to find out the reactions at the support in case of the propped beams. In the next video we will solve some different topics of strength of material. If you like this video, please share and subscribe this video. Thank you.